Okay, ran out of battery about the time I was starting this, so let's continue. Okay, so let's work backwards again from our conclusions. We concluded that we've compounded at 12% annual interest 6 times a year, starting with $1,000. Okay, well, compounding 6 times a year at 12% annual interest means we get 1/6 of 12%, or 2% every time we compound. And we compound 6 times every year. So 1/12 of 6% is 2%. And we do that 6 times per year. So in T years, how many times will we be compounding? Well, we'll be compounding 6 times every year. Multiply that by the number of years, that's going to be 6T times. So we're going to add 2% to our existing principal 6T times in T years. That means we're going to get 1.02 times 1.02 times 1.02 6T times. That's 1.02 raised to the 6T. And we're going to get this multiplied by our starting principal. And I said times, and I used the word times 2 different ways. So maybe this times should read multiplied by. We multiply this by our starting principal. That's what we have here. We have 1.02 raised to the 6T multiplied by our starting principal, $1,000. So we proceed, and I'm going to pose this, and you should think this through if you haven't already done so. And you would have done so hopefully during class. But without referring to your notes or anything, tell me what it means if P of T is $8,000 times 1.01 raised to the 4T. You can compare with what we did here, but make sure you understand the reasoning as well as how to imitate what I just said here. Okay to imitate it, but then stop and think, okay, how would I do this if I didn't have this example to imitate by? Because this is something you'll be well rewarded for understanding. Now you should stop there and do this, but we're going to continue with a summary of what we did in class. Okay, so here is the function I asked you to analyze. And people didn't do real well with this, but it's been a few weeks, you know, there's a lot of stuff. Every step of what we've done is pretty easy, but you need to remember how we got every step. You need to remember what to do at every step so you can understand how to put it together. So, $8,000 times 1.01 to the 4T. What are our conclusions? What's our initial principal? Well, that's easy. That's the $8,000. Okay, how many times are we compounding per year? That's the easiest. That's the next easiest question to answer. And if we're doing, if T stands for the number of years, then raising this to the 4T means we compound 4 times every year. Then 1.01. Okay, well, for compounding 4 times a year, the 0.01 represents what we're adding each time. And if we're adding 0.01 4 times each year, that means our annual interest must have been 4 times the 0.01, or alternatively, the 0.01 is our interest rate divided by 4. In any case, our interest rate is 0.04. So we have 1 plus 0.01, okay? And that represents 4 compoundings per year. So we're adding 0.01 4 times a year, so we must have had annual interest rate 0.04, so that when we divide it by the 4 times per year, we get 0.01. Okay, then we answer questions related to this model. First of all, how much money do we have after 5 years? Well, that's a straightforward calculation. P of T is how much money we have after 2 years. So if we let T equal 5, we have P of 5, and that's going to be the amount after 5 years. Well, P of 5 we get by plugging in 5 for T, so T had better be 5. So P of 5 is $8,000 times 1.01 to the 4T, but T is 5, so it's 4 times 5. And we multiply that out, we get $9,761. At least if I believe what your calculators seem to always be telling me. And people did fairly well with this, okay? After 10 years, well, it's P of 10. So we just do the same thing. We plug in 10 for T, We're going to have 40 here, 1.01 to the 40th multiplied by $8,000 gives us $11,907. Okay? Now, next question is, how long does it take our principal to double? Well, if we start from the original time, the time 0, let's say, at time 0, the principal is 8,000. So at what time is it double that? That's how long it's going to take to double. So we go from 8,000 to 16,000, okay? So that means that 8,000 times 1.01 to the 4t equals $16,000 when t is equal to the time it takes to double. There's our equation. How do we solve the equation? What's the most obvious thing we can do? We're trying to get t, right? Most obvious thing we can do is divide both sides by the 8,000. We have to understand the algebra well enough to know that, that's a valid step. Divide both sides by 8,000. And when we do, things get a lot simpler. We just have the 1.01 to the 4t left on this side. On the right-hand side, 16,000 divided by 8,000 is 2. So now we have the equation 1.01 to the 4t equals 2. Well, we've known for nearly a month how to solve this equation. We simply change it to logarithmic form. We get log base 1.01 of 2 equals 4t. Now, I haven't written out the rules for that because you should be used to them. And if you aren't, and that might well be because it might have been a couple of weeks since you thought of this, since you thought about this, yeah, you should think about it now. Okay, review that. Make sure you understand that this is an easy equation to solve if you just know how to convert between logarithmic and exponential form. Okay, if this expression equals 4t, then you divide both sides by 4. T is then going to be this expression, which isn't very easy to read, log base 1.01 of 2, same thing we had here, divided by 4. And that's 1/4 of log base 1.01 of 2. And log base 1.01 of 2 is log of 2 divided by log of 0.01. And this comes out pretty close to 18. Now, you could have gotten 18 using the rule of 72. Okay, if you know the rule of 72, you just divide 72 by the annual interest rate, 4%. So 72 divided by 4 gives you 18. So this should be close to 18. Okay, but maybe it's a little more, maybe it's a little less. And of course, if you're working in finance, and you might not end up working in finance, but if you happen to be working in finance, you'd better understand that you better get this down to the second. You better get this number accurate. Still, for financial planning the future, not knowing exactly what the interest rate will be, you say, well, if the interest rate stays around 4%, it's going to take about 18 years to double our money. Again, if you need a more accurate result, you'd better do the calculator, and you'd better be able to solve this equation. So, next thing I asked everybody to do was sketch a graph of the 2 to the x function. Some people were pretty good with this, but not good enough, not fast enough, and there were too many errors. We need to be able to do the graphs of the basic functions instantly. So, the instant graph, well, we're going to use t-values 1 and 2, and -1 and -2, and of course we've got 0 in there. And we're going to use y-values, or in this case, it's going to be p-values. And actually we're not doing t and p, so let's just start with x and y. Okay, and our y-values would be 1, 2, 3, and 4. Then, knowing where our points are, we know we have a point here, we know we have a point here, we know we have a point here, and I'm not going to explain this. We know this point is half as high as this one's half as high as this one, so right there we have a pretty good graph of y equals 2 to the x. Okay? Now, we're going to take that graph, but we're going to say, okay, I don't want y equals 2 to the x. Really, what I want is, I want